Greetings and welcome, friends. Today we are talking about logarithmic functions. That's right, you've seen these before a little bit in Algebra 2 / Math 3 equivalent. But we're going to do a quick little review of some of them today. So logarithmic functions, the first thing I want to do is compare a function y equals 5 to the x, so that's an exponential like the ones we were dealing with yesterday, and its inverse, which would be x equals 5 to the y. All right, so if I graph these, here's the exponential function, and here is its inverse. Now, you might recall this about inverse functions, is that they are mirrors over the line y equals x. I'm not sure. Do you guys remember that? Yeah, maybe a little bit. So that means that the inverse is the mirror image, and instead of having a asymptote on the x-axis, it's on the y-axis, and so forth. So notice that instead of 0, 1, it's got a point at 1, 0. Instead of 1, 5, it's got a point at 5, 1. And really, the concept of inverses is just switching the x's and the y's. So here, the domain, I'll get rid of that, is the set of all x, right? It goes from negative infinity to positive infinity. And also says that there. And the range is all values of y that are greater than 0, right? Because it never equals 0 and it's never less than 0. So that's what we see there for the domain and range. The domain here is the set of all x that is greater than 0. It's never equal to 0 or less than 0. So it's kind of the domain and range got switched is kind of what happened. And the range is the set of all y. It goes from negative infinity all the way through to positive infinity. So this never flattens out or anything. It just keeps getting horizontally larger and larger, but still does keep making progress in the positive y direction. So so that's some differences there between those. And you might have realized I actually rewrote this x equals 5 to the y as y equals log base 5 of x, because it turns out that logarithms are the inverse of exponential functions. Yes, yes indeed. So let's take a look at this here real quick. So a logarithm, let's see, it says in the function x equals a to the y is called the logarithm of x. And this is how it would be written. A is written with like a little subscript, so it's not the same level or font size. It's like an exponent, but hanging out down low. And this is read out loud as y equals log base a of x. I don't usually say the log, just plain old log base a of x. And so that's the idea there. And also notice the way some of this gets rearranged. Right here, the exponent became what it's equal to. Here, the base is actually in agreement with what the base is here. Right? Both of those actually even use the same language, the word base. And then x is the power. So x is there. So that's what the logarithm looks like. And we're going to do a little bit of different work with that in a moment. But I also want to talk about what a logarithmic function is. So a function is when we would then have something that could be graphed, have inputs and outputs, and so forth. So actually this should probably say logarithmic function. That's fine. So it says the logarithmic function y equals log base a of x, where a is greater than 0. All right, so the base cannot be negative or 0. A is not equal to 1, so it also cannot equal 1. That's for a variety of reasons, but it kind of is just not an interesting case in that point, and it's actually no longer has the curved nature of the logarithmic function. It says, is the inverse of the exponential function y equals a to the x. So y equals log base a of x if and only if x equals a to the y. Same sort of relationship here. The only thing it's doing is talking about it as a function with inputs and outputs and what sort of restrictions there are. So the first skill we should have is being able to convert from logarithmic form to exponential form. So here we are. So write each equation in exponential form. So here I've got what would be read as log base 125 of 25 equals 2/3. And what this could be rewritten as in exponential form. So remember, this 125 is the base. So that is going to be the base in my exponent. The power is actually what the 2/3 is equal to. And that would equal 25. So this is in exponential form. So the 25 goes here, or sorry, the 125. So that's kind of how it gets rearranged. And actually, one of the ways that I think about logarithms is when I see log base 125 of 25, I think 125 to what power is 25? And this is the power that it's raised to, is the way you think about that. So that's in exponential form, and if I wanted to verify this, I think you guys would agree. 2/3 power is the same as the cubed root. Oh, that's so that's the same as the cubed root of 125 all squared, and the cubed root of 125 is 5, and 5 squared is 25. So just to verify that it's true. However, they weren't interested in that. They just wanted us to redo it like so. So let's do another one. Why not, shall we? Same instructions. So log base 8 of 2 equals 1/3. This would translate into exponential form. All right, exponential form is where it won't have the logarithm showing up anymore. So this would be 8 to the 1/3 power equals 2. Is exponential form for this. Right, so the base is still the base. So this, when I look at this, this asks the question, log base 8 of 2 asks, 8 to what power is 2? And 8 to the 1/3 power is 2 because the cubed root of 8 becomes 2. Let's try converting in the other direction, where if I give us exponential form, could we write it as a logarithm? So here's the base is 4. So this must be log base 4 of something is equal to a power. So log base 4 of 64 is equal to 3. So in the case of logarithms, it's equal to the exponent, excuse me, or the power, right? So the thing that the logarithm is equal to is that. So this is now in logarithmic form. So it's just a matter of kind of knowing what goes where and being able to rearrange it as need be. So 3 to the -3rd is equal to 1/27. So this would be log base 3 of 1/27 is equal to -3, right? Because the power or the exponent is what the logarithm is equal to. That's what it's asking us about. Right, so when I see log base 3 of 1/27, that asks me the question, 3 to what power is 1/27? And that is the -3rd power. So, not too crazy perhaps so far, but let's actually now use some of our conceptual knowledge and evaluate some logarithms. So that's all been just like rewriting. Only a couple of more examples here. So what if I wanted to evaluate log base 5 of 125? And this asks me the question, 5 to what power is 125? All right, that's the question it asks. And if I wanted to, I could say, well, if I'm trying to evaluate this, I could just say, oh, well, let's just let this equal x, for instance. And when I ask the question 5 to what power, that would be 5 to the x equals 125. And you might be able to answer this question logically on your own if you just happen to know your powers, so to speak. Does anyone know 5 to what power is 125, what that would be? Yeah, that would be the third power. The other way you can do it is 5 to the x equals, I could have rewritten 125 as 5 to the third. And then you might realize here's two powers that are equal, their bases are the same, therefore their exponents must also be the same. So x equals 3. But that's not necessarily as intuitive. However, there will come a point when we have to solve these where it doesn't happen to be a nice power. Like if this was 124, for instance. And that's where we'll actually be able to use calculators or logarithmic tables to be able to answer that sort of question. But yeah, logarithms are most effective in dealing with exponents, that they actually allow us to solve equations that have, whoa, getting a little lag there, solve equations that have variables in exponents in situations where it doesn't happen to be obvious for us. So, so here's our last example that we'll evaluate. It says log base 7 of 149th. So this is asking me the question, 7 to what power? Man, I'm getting lag. Oh, my tablet's dying, that's why. Poor signal. Come on back, Tabby. Here we go, it's coming, it's coming. 3. Oh dear. All right, oh, it's back. Haha, here we are, I've returned. Okay, and I've got some, there we go. So 7 to the x equals 1 over 49. Now, I don't know if you guys realize this, 1 over 49 is the same as 1 over 7 squared, right? Which is the same as, I could actually rewrite that as 7 to what power? -2. So x must equal -2. So right now, since we are more familiar with exponents, most of the time when you're trying to evaluate a logarithm, you're probably going to convert it into exponential form and then try to figure it out from there using your skills in that realm. But we're going to do some more with logarithms in the next lesson with all sorts of different properties, and you will eventually be able to evaluate logarithms or find estimates or approximations, sorry, of logarithmic values when it doesn't line up super nice. And that's when we use calculators or tables, as I said earlier. All right, thanks for watching, Internet friends. Tienen un día al más bien del mundo.